So in the last video, we made text from TTF font, and we didn't get a chance to move it. So this video will continue on from there, but we're going to actually make the font move around the screen. So in this one, we will continue on right from where we left off in the last one. So if anybody is joining, you're going to need to clone the repo over here, and we're going to be in the clone this whole SDL2 examples repo, and we're going to be working in C SDL2, and we are continuing on from 05 create text. This is where we're continuing on from. Okay. So right away, I'm just going to take this file here and copy it and rename it to the new one. Let's call it 6 moving text. That sounds good. And we'll go up to the top. Moving text. Okay, so basically all we need to do to move this text around the screen is we need to change the rectangle. There's the destination rectangle when we're, where is it at? Right down here. When we draw this to the screen, we have this destination rectangle, the text rectangle. If we just change the X and the Y, we can move it, right? So if we do that every frame, if we keep changing it every frame, we're going to move it around the screen. So let's try that real quick. So let's set an X velocity and a Y velocity. Or we could just try 1. It doesn't really matter, but. I'm just going to say 3 so it doesn't move too fast. Now this, again, this is not managed. This is on the stack, but it's easily accessible. Text yvel. Okay, so that's just xvel, yvel. That's just for velocity to move it around. So we're going to be moving 3 pixels every frame. So we're going 60 frames a second. We'll be doing 180 pixels per 180 pixels per second. That's the speed at which the text will be moving. And what we want to do is we want to put this into a function, like an update function. We'll just call it text update. So I guess just right down here at the bottom. And this is, we're not going to worry about any kind of error happening. We're just manipulating the X and the Y number. So there's nothing super important happening here. This is not going to be returning a bool. This is just going to be a void. Okay, and we can do something just really simple just to make sure it's working. We could say game text rect, say dot x, and we could say plus equals game text x velocity. We could just make it as simple as that, or we could do both of them. No, I should have. Y. And the reason why I have these as that I set them as int and not the reason why I didn't put it up here as a constant, but I set them in here as an int, is because we're actually going to make it where they're going to change. So they're positive numbers right now. They're moving at 3, but when we want them to go the other way, we can change those positive numbers to a negative number. So this is going to be a mutable variable that we're going to be using here. But for right now, just to see it happen, we're just going to make this simple function. We need to forward declare it. It doesn't matter what order it is, but I just kind of want to see what I'm doing. Yeah, I just threw it underneath. And okay, so we have our function declared up there, defined down below, and the place that we're going to call it is right here. So each frame each frame of this while loop, we are checking all of our events, whether it was a close event or a key button event. And when that's all done, we're going to run our update, which is going to change the rectangle, and then we're going to draw our frame. We're going to clear the render. All this drawing stuff happens here, and then the delay, and then it happens again. So right here, we are going to call this function. And we're sending in the game. That is right. Yeah. We're sending in a reference to game. So let's just see if this works. Okay, we need to change our for 6 moving text. Well, that wasn't very interesting, was it? All right. So it should have been moving, but it wasn't moving. So I've definitely made a mistake somewhere. Well, this is a mistake, but that's not what's causing it. Okay, so text rect, and we are using text rect to, yeah. We have these. And we are calling this function. Well, let's see what's happening. Let's see if we're updating. I know what it is. I've made a mistake. It's the text file that I'm editing. I am still working in 05 create text. That's what's going on. So before we go too deep into this, let's fix this. So I've made a second file here, but the problem is I've continue editing this file. So real quick, I'm just going to fix this. I'm going to delete this file. And I'm going to copy this one. Now I have that. I'm going to go back here. I'm just going to undo to get back to where I was. Let's see. I think right there. That's where I was. Okay. Now, hopefully this will do what we wanted it to do. Yep, there it goes. And there's the problem. So a couple things happened here. The reason why we got all this spit out at the end is because that was when when the buffer was full. Um, I did not give a new line character right here. So we don't actually need this anymore, but I should have give it a new line character. So that was a bonehead thing I did. Let's try it again. There it goes. And the problem is it keeps on going. So we kind of need to deal, this whole video is going to be dealing with that. So we need to start checking whether it has gone off the screen or not. So right away we're let's make this a little bit bigger so it's easier to read. Right away we are updating. That's just fine. But after we've updated, let's start checking to see if we've gone beyond bounds that we want to check to see if we've gone. So the way we can check if it's gone over the screen to the right is we take the X, which is the leftmost part of our rectangle, and if we add the width to it, we're going to get the right side of it. And if we see if that is bigger than our constant up here of our screen width. So if it has exceeded the screen width, so we're taking the X and then we're adding it the width, and we're going to see if that's bigger than the screen width. Text rect dot X plus text rect dot width. And if that's bigger, then screen width. So if we've done this, why don't we just switch the direction? To check the X, why don't we just disable this one? And what we'll do is we will multiply the X val by -1. So where is that times? All right, so let's just see if this works for us. We'll put the other one, game text rect dot X is smaller than 0. I don't like this because we don't know if we're how far we're past the screen. So why don't, instead of this, why don't we say, well, we could use a magic number, I guess. We could say equals -3. And it'll be going the other way. Okay, let's see what this does. Okay, that looks pretty good. All right. So it's not fancy. If it's bigger, I'm just literally, so even if I were to go past, say I went deep into the screen, so the next iteration was still in the screen, if I would have done multiply by -1, I would have had it suddenly trying to come away, but it's still embedded in the screen and trying to go back the other way. This way, it's just, if you're on that side of the screen too far, we need to be going the other way. And then if you're on the other side, same thing. So we'll just do this exact same thing with the Y's. I said this is nothing fancy going on here. Do the Y, and this will be height, and this will be screen height. And we're changing the Y. Let's see. Screen height is bottom. Yeah, that's still the same. I do everything right here. Right. Yes, it looks good. Oh, that was pretty good. Now this again, we're just using this 16 millisecond, giving us about 60. It's not really 60. That's going to be beyond the scope of this. I just want to show movement. This is just a very simple way of doing it. You could use floating point numbers and everything, but it's when you're making a little bit more complicated games that you're going to be managing the FPS a little bit better and managing your movement with delta time and everything else. But this is just very simple showing of movement. I actually like this, but I kind of want it to not start. Let's see, right, where does it start here? It starts right at this top corner. I kind of want to maybe move the X in 100 or something like that. The initial X. Wait, did I do that right? What did was it 100? 200 maybe? I didn't see if it was actually 100. Save it. Run. Yeah, that definitely. Okay. Maybe 100. I don't want it to be directly hitting the corners. It's a bit, it's not as exciting to watch. One more time. Okay. The next one, we're actually going to be loading an image for a sprite, and then we will control the movement of that one ourselves. We'll leave this one to bounce around the screen by itself, but we'll have our own image that we can control with the arrow keys. So let's just walk through this one more time. Nothing major happening here. We made a function down here. We've created two variables that hold our velocity that we can change to -3 or 3 right here. And we got our function down here where we're just adding it. So if it's 3, it's just going to add 3 to it each time. If it's -3, it's going to add -3 to it each time. And we're just checking, hey, is the X the leftmost part of the image plus the width? That gives us the right part of the image. Is it bigger than screen, which would be over here? Or down on the other one, just X, that's the leftmost part of the image. Is it smaller than 1? And it's just a very simple way to have it bounce around the screen. So nothing too exciting. I just couldn't tack this on with the other video. It was just too long. and we're updating it right here before our drawing happens. So we're checking events, we're updating, and then we're drawing and rendering. And there's nothing to clean up here. There's no resources that we're managing. So that's going to be it for this video. I hope you enjoyed it and learned something from that. And then, like I said, the next one will be loading our own image and controlling the movement of it ourselves.